and then you calculate the remaining offset and save it into the byte offset, and you call it seek again within the block to move it to the right byte offset. Okay. All right, so let's look at the answer here. So when you calculate this block offset, you just use the divide, right? And it will give you this block address. Then you use the remaining, right, to get the byte offset. Okay. As again, first time when you seek, you want to keep this origin, okay, because sometimes it's not necessarily always from the beginning. Depends on the scenario. You could seek from, well, I understand it's not necessarily makes sense to seek from the end, but one still makes sense, like the existing location. That makes sense. So you want to keep this origin argument unchanged. Then the second seek, yes, you have to change it to 1 because that makes sense to seek from the 0 again, but using this byte offset. All right, so this is how you can do it. Again, this is the old days, right? In the old days, this first machine, when they design for this machine, they create this seek function. In the future, they realize that, oh, it's too small. Our file is way bigger than that. So they create another function, but they cannot call it a seek again. So that's kind of for compatibility reason. That's why they create a new function called long seek. All right, next function is the file function. Okay, so we have a bunch of file functions. First of all, let's look at the file pointer. Again, when we using this fopen function, we're getting a pointer as a return rather than a file descriptor, right? That's because the file pointer is pointing at a structure, a custom structure, which contains a lot of more information than just the file descriptor, right? It has file descriptor. It has the flag for read or write, or end of file or error, etc. It has a pointer to the next location in the buffer, right? That's the n. Oh, sorry, not the n. It's the buff p, right? And it has the count of the number of characters left in the buffer, which is the n we have showed. Finally, it has the pointer to the buffer itself. All right. So it contains all the information we have just looked at it before, all packaged together into a file structure. So this is how the file structure could be looked like. It's still a simplified version of it. Using the underscore here is to make sure those names won't be duplicated from the other variable name user defined. Okay, because this is the storing the standard IO library, right? So okay, so when we initialize this standard in, standard out, standard error, essentially we're just creating a file descriptor based off the value from array, which we'll look at later. All right. So essentially the array saves all the necessary information to flag this is the terminal input, terminal output, and terminal error message. Right. Imagine that this last one is 0, 1, and 2. Right? Other things are, you can imagine they're similar. Okay. So now also let's look at some macro. Okay. Please keep quiet. Okay, unless you have a question. Okay, yeah, if you not talking about something about the course, please keep quiet, or you can always chat to each other, but do not make phone call. Okay, yeah, do not talk to each other. Okay, yeah, you can chat. That's no problem. All right, so this is a macro to replace this getC function, right? The getC function essentially is just reading from the buffer, right? We have a buffer, and we have this buffer pointer, right? The P is pointing at our file structure, right? And then as long as the count inside the file structure is greater than 0, we will keep reading from it. And then we will return the value from this file buffer pointer, and then using this mask, right, to cut off the part at the beginning of this integer character thing. Otherwise, we will call the function to fill the buffer. Right? Again, this is a very condensed version of the read character function we just looked at before. Right? If we have enough number in the buffer, we'll read it. Otherwise, we'll fill it up. So similar idea is to put C. Right? I'm not going into much details, but you can imagine the same idea. We can check how many write buffer we have. As long as we have enough size in the write buffer, we will keep writing to it. Otherwise, we'll flush it. Flush means we save all the information in the write buffer into the real file, into the hard drive. Then we clear out our write buffer. Right? The same logic. So with those in the mind, we can finally look at this file open functions. So the file open function do multiple things. At the beginning, it's trying to set all the flags right? It's what's the mode? It's a read mode, write mode, append mode, right? It is, does it has any read or write flag or anything? Do we have any free slot in our system, which is quite a lot operations. But more importantly is, okay, so once we determine that we're in the write mode, right? This is the argument the user passed to us, right? The write mode. That means we're going to use the create function, right? Create function to create a new file that potentially might override your existing file with this p mode. Otherwise, if it's a append mode, you will open the file, and if you cannot open this file, you create a file, right? After that, you will use the seek to move your pointer to the end of the file. That's how you append the file, right? And finally, if it's none of the case, you will open this file as a read mode, right? So you can see, so when we are calling this file open, right? When we calling this file open, we only simply just tell the name of the file, the mode of how we want to read it. But internally, it's doing a bunch of things, right? It's initialized the entire structure for the file, and it's deciding either it should create a file or open a file, and if it should seek it to the right location or not, right? Setting up everything for you. Similarly, okay, another example is the fill the buffer. Okay, so the fill buffer is to allocate enough space for the buffer and to fill the input into this buffer. Right, so here we have two modes. Ignore those flag checking part. So at the beginning, it's trying to find if we have already identified a buffer space or not. Right? The first time you're calling it, obviously, is no space has been determined for the buffer. And then you have to trying to see if we're trying to use a small buffer or big buffer. Okay, what does that mean? Small buffer means there's no buffer, just one character at a time. Big buffer is basically you have to allocate the size of your buffer size, for example, like the block size, right? Create that kind of space, and then you can set your flag to the right one, means either for some reason you run out of your memory, so you have to force yourself to use this unbuffered situation, or you successfully allocate enough memory, so that way you set your flag as a big buffer scenario. After that, you update your base pointer to the right pointer location. So the next time you're calling this again, you know you already have this buffer. You don't have to set it again. With that in your mind, then you can start to read things from this buffer, right? The reading from the buffer part is, we have seen that before, so not necessarily too surprised. Then if our count is smaller than 0, if something is wrong, right? Then you can say it's either it's end of the file or it's an error. Those are all saved as a flag inside your file structure. When you return it, you also want to mask it to make it a positive character. Again, quite complicated, right? As you can see, so many lines just to fill the buffer for you, because there's a lot of flag to set inside the file structure. Finally, we can look at the array we have talked about before. That's the IOB array. The first one is to set the standard input. Second one is standard output. Last one is standard error. Right. So those are the all the flags and the file descriptor you need to initialize those special files, file structures. Okay, so before we wrap up, this is our third assignment question. Is to let you write a function called flush buffer. Okay, similar to the read buffer we just looked at it. We're now using this write buffer function. There are multiple requirements for this function. So essentially, it has to save whatever you're going to write into the buffer first, right? And then until it's full, it's then going to write to the disk. But when it's beginning, there's no buffer existing, so you have to allocate enough memory space for it. And also you want to handle the situation as unbuffered output. Means either you just, the flag itself is set as unbuffered, so you output one character at one time, or because of the run out of the memory, so you have to use the unbuffered situation. So 4 steps: file check if the file is existing. Then the second will be allocate the buffer in the memory, write the buffer content, and reset the buffer, right? The challenge with this creating this assignment answer is you cannot test it. Again, because in our online compiler, there is no function for you to read or write files. So instead, I will set up this assignment as like a matching question. So you have a bunch of optional code, and you have a bunch of empty lines in your code. You just tell me which code will be inserted into which slot. So I will set up this assignment as a quiz, because quiz allow me to set up different type of questions rather than just a PDF file, right? I will set up as a quiz, but you can still work on this unlimited time of quiz, as long as you submit the quiz by the due date. All right, that's essentially how it works. You will see, oh, it's assignment 3 is a quiz, but don't worry, it's not a real quiz because you just do it at home, take whatever time you will need. I haven't set up yet. I just let you know I'm going to do that for the assignment 4. Okay, yeah, so you can. Also, we will have a similar question in our final exam. So this is your chance to practice this, like how does that work? This type of question. All right, wrap up. So we're talking about some lower level C functions, and that's give us direct system level I/O capabilities. If we're using well, they are very, very efficient. But if you're not doing that well, for example, you didn't set up the buffer properly, your performance will be very, very poor. But the essential idea is that you understand how the other function we have talked about so far, like file open, get character, put character, has been made using those lower level functions. The point of doing that is whenever code you're writing using those higher level functions, they will keep compatible across the systems. All right, and while using the lower functions will ensure this performance of your functions. All right, that's it for the lecture today. I will see you next Tuesday in the classroom again.
Sorry, I have a question.
Sure.
I didn't understand what you were saying about the assignment 4, because we already have the question 1, so I was already working on it.
Sure, you can still work on it. So yeah, we have 3 questions so far, right? I may add one more question to it, but first 2 questions, okay. First of all, the assignment will be set up as a quiz. Do you understand that part? So in Moodle or on Brightspace, you will see an exam or quiz called assignment 4. Okay, inside of it, you have 4 questions, for example, right? First 2 questions is just written response. You can paste your, just upload 2 files, right? Like one is screenshot, one is your source code. Those 2 is just like you do the assignment, but just the third question is a matching question. So you have to drag and drop those answers into the right location.
Okay,
Does
I
that,
see.
yeah, make sense now?
No, yeah, thank you.
Okay. Yeah. You have work on the first 2. That's fine. You just save your results somewhere, then later on you just upload them. Yeah, no worries about that. Just for the third question, you don't need to program it from scratch. I will set up the quiz so you can drag and drop. All right. Okay.
Thank you.
You're welcome. And let me stop recording.